We are now ready for problem 9 from these test review problems for the final exam. I think what I'll do on these problems is actually try and show you the problem in my math lab and then work through it. Now I have the answers on my sheet, so I'm going to try and cover them up as I work out the problem. But then it's good that I can check the answer to make sure I don't obviously make a mistake or mislead anybody. So for example, here's problem 9. So now we are in the section about polar coordinates. So once again, these are review problems. So I'm not going to teach these principles, but just show you how to work these problems. So this one says, plot the point given in polar coordinates. Now this is a multiple choice, but I'm actually going to also sort of cover these up. Let's just go ahead and plot this on our own, and then we can see which answer is correct. So when there's room, I may just work on my paper here. So here, I think I can fit it in. So polar coordinates, R is the first number and the angle theta is the second number, right? So you always graph your angle first. So where is the angle pi over 2? Well, pi over 2 angle is straight up. It's like the positive y-axis. Now the distance or the length from the origin is r, which is 9. So if I just mark like here is a distance of 9. And basically right here is my polar coordinate. So that point right there in polar coordinates is 9 pi over 2. So just to check, if we look at our answers, it's not always easy to tell, but you can see here, the answer should be A, which the answer is A. All right, pretty straightforward. Here's the second problem, another plotting. Here now, the points in polar coordinates, now it might at first throw you off. It looks like it could be an XY coordinate, but this is in polar coordinates. So R is the -3. And the angle theta is 0. So once again, this one should be pretty easy. Matter of fact, I might use some. I'll start with the next problem. All right, so let's go find the angle first. Well, where's the angle 0? Where the angle 0 is basically the positive x-axis. So here is the angle 0, but you notice the R is -3. So that means like if 3 was right here, this point here would be 3, 0, R3 theta 0. But our R is -3. So what you do when you have a negative R, you just flip the angle 180 degrees. It's like you go to the opposite side of your graph. So in other words, if 3, 0 is right here, -3, 0 is going to be right here. So it's an angle of 0, but the -3 causes you to go in the exact opposite direction. So this is -3, 0, and it looks like it would be this one right here, assuming that's 3, 1, 2, 3, -3, so it should be A again, which it in fact is. All right, so not too difficult, these polar coordinates. One more polar coordinate problem, or maybe there's more than one, but I should say here's another one. Number 11. Another time when we want to plot a polar coordinate. So this one is -4, 5 pi over 6. -4, 5 pi over 6. I'm going to actually do this. So once again, R is -4, theta is 5 pi over 6. You always do the angle first. Think about the unit circle. Where's 5 pi over 6? 5 pi over 6 is over in here, right? That's 5 pi over 6. What's our R? -4. So +4 would be right here. So -4, we go in the exact opposite direction. And that's a distance of 4. So that's the R. And then the 5 pi over 6. So this is our point right here. That point right there is -4, 5 pi over 6. And we can see what the answer is. Should look something like this right here. It should be C, which it is. All right, number 12. Actually, it's another one. Number 12 is finding the point in polar coordinates -3, -pi. Just to make sure we're totally clear. There's my angle. There's my distance, R. You always do the angle first. Where's -pi? Well, normally counterclockwise are how we do angles. So if we have a negative angle, we go clockwise. So a -pi would be right here. But then we're going to go -3. So say if this was 3 right here, if that was 3, our point would be here, but -3, it gets flipped over here. And our point should be right here. So in polar coordinates, that point is -3, -pi. We can check. And so it should be this point right here. The answer should be B. And the answer is B. All right. Now we're ready for number 13. All right. Now here, I have a little twist on a polar coordinate. So here's an interesting fact about polar coordinates. So they give you a point in polar coordinates, 3, 7 pi over 6. And you notice in polar coordinates, like we talked about in the lecture, you can have the same point be represented by different polar coordinates. In other words, the same exact point on the graph, but it can be called different things. The r can be different, the theta can be different, or both the r and theta. So that's going to be the point of this problem. So the first thing they want us to do, they want us just to go plot 3 7/6. And then what they're going to do is they're going to want us to then go and plot that same point, but change the polar coordinate. And then A, B, and C tell us how they want us to change the polar coordinate. So we'll get to that in a minute. But the first step is to actually plot 3 7/6. So you do your angle first. 7/6 is right here, a distance of 3. We'll just call it right here. So that is 3 7/6. Here's what they want to do. In part A, they want us to plot this same point, but now here they say r greater than 0. That means r is going to be a positive number. And they want the angle to be between -2 pi and 0. So basically, in my mind, they're saying, okay, give a polar coordinate to this point, except r is positive and the angle is negative. Well, negative angle means you go counterclockwise. So if this is 7/6, what's the angle going to be if I go in the negative direction? Well, I know that this distance is pi/6. So you could think if all the way across this pi and I'm stopping pi/6 short, what is this going to be? -5 pi/6. So for A, r stays positive and is 3, but my angle is -5 pi/6. For part B, now they say they want r to be negative and they want the angle to be positive. So once again, I need to end up back at this point, but I need to have r negative and theta positive. So really what I need to do is, since r is going to be a negative number, I know it's going to flip to the other side. So what I need to do, I need to end up like right about here with my angle, and then the negative r, we'll put it here. So what's this angle going to be? Well, it's the same as this angle here. So the angle is going to be pi/6. And when I make my r negative, then -3 pi/6 should end up right here, right? Because your angle is pi/6, the -3 flips it over here. And then the last one, part C, says, how about r is positive? And now something a little different. I actually want the angle to be between 2 pi and 4 pi. So really what they're doing is, we of course need to end up back at our point, but what they're going to do is, they're going to, in a sense, they want you to go around the circle once, which is 2 pi, and then stop here. So pretty straightforward. R is going to be 3. So from here to here is 7 pi over 6, but instead they want us to go 2 pi and then 7 pi over 6. So it's almost like our angle is going to be 2 pi plus 7 pi over 6. Well, to add these together, you need to get a common denominator. If I change 2 pi to denominator of 6, it actually would be 2 pi is something as 12 pi over 6. Add these together. 19 pi over 6. Now let's confirm that I didn't make a mistake. So the first part is just to graph this point, which should be down here called C. Oh. The answers are way down at the bottom. Sorry. The answer is C. And then for part A, the answer is 3 negative 5 pi over 6, which matches up with what we found. So this is part A. Part B, negative 3 pi over 6, which is what we have. And then the last one should be 3 19 pi over 6. 3 19 pi over 6. So that just confirms that we did it correctly. All right. So continuing on. What we have here. Now we get to a point where they give us a polar coordinate and they want us to convert that to a rectangular coordinate. So now you have to remember how to convert back and forth between polar coordinates and rectangular coordinates. So let's just quickly look at those formulas, which we're going to use. So we have r theta polar coordinates and xy rectangular. Here's the equations we use. If we're given like this, if we're given polar coordinate and we want to find x and y, x is r times cosine theta and y is r times sine theta. So it's pretty straightforward. R is -4 cosine of theta, cosine of 7 pi over 4. Now, you know, from our unit circle, hopefully you've even now got these memorized in your head. 7 pi over 4 is over in the fourth quadrant, right? 7 pi over 4 is right here. And we know the cosine of that is square root of 2 over 2. So -4 times square root of 2 over 2. Unfortunately, I'm running out of room here. So if I can squeeze it in. Well, the 4 and the 2 reduced down to 2 over 1. So it's actually going to be -2 square root of 2. So the x is -2 square root of 2. Now, what I suggest you do on these problems, just as a check to make sure you don't goof up, if we look at this actual, let's just make a quick plot. I should have done this to start with, but let's do it now. Let's make a quick plot of where this point is. 7 pi over 4 here, but -4 causes it to maybe be over here. So there's the point, -4, 7 pi over 4. What I need to do now, as I'm working on my x and y, I need to make sure it makes sense. I'm saying x is negative 2 square root of 2. Well, that makes sense because over here, x is definitely a negative number. So that looks good. Let's see what happens when we do the y. So negative 4 times the sine of 7 pi over 4. The sine of 7 pi over 4 is a negative square root of 2 over 2. So for this one, we have negative 4 times negative square root of 2 over 2. So it turns out this is the same as x. The math is the same, except this one's negative, but these two negatives make a positive. So it's going to be 2 square root of 2. So my point should be a negative x, positive y, which that's what that is. And these should be the values. And now we can check. And as it turns out, negative 2 square root of 2, 2 square root of 2. Very good. Now the next problem, 15, the rectangular coordinates of a point are 7, 0. So that's x and y. Find the polar coordinates. Now, we do have equations. Let's just write those equations down, although this one is simple enough. I don't think we even need to use the equations. I mean, you could, but you don't need to. So say you have you're given rectangular coordinates, you want to go to polar. The equations are r is square root of x squared plus y squared. And then theta, which gets to be tricky because theta is the inverse tangent of y over x. Anytime you do inverse tangents, you always have to make sure your answer is actually what it should be. Sometimes you have to use a reference angle. To make this one simple, I don't actually need to use these equations. Let's just go plot this point, and I think it's going to be pretty obvious what the polar coordinates are. So in other words, 7, 0. It's like right here. All right, so that's the point 7, 0. So what would that be in polar coordinates? Well, obviously, the distance is 7, and what's the angle? The angle is 0. So this is xy. Turns out polar coordinates is actually the same thing. Although here, 7's x, 0's y. Here, 7 is r, 0 is theta. It's almost like a trick problem. And there's the answer, 7, 0. All right, number 16 is the last one on this page. The rectangular coordinates of a point are given. Find the polar coordinates of this point expressed in radians. So now, all right, so here's another one. They've given us rectangular coordinates, and they want us to know polar coordinates. So let's just say and we want to figure out how we would express that rectangular point in polar coordinates. So now we are going to use our equations. So first, let's plot this point once again. Sometimes even I forget, but it always makes sense because it helps you to make sure you're doing things correctly. So 8, negative 8. So let's say, I don't really need to have the circle here, but let's say 8 is here, -8. So there's 8, -8 on the XY graph. Now, polar coordinates, to find R, square root of x squared plus y squared. X is 8 plus y is -8. Be careful now. You're squaring the -8. And what happens when you square a negative number? It's positive. So this is really 64 plus 64. Now, in the world of math, whenever you have a radical, you have to always simplify if possible. So once again, I don't have time to describe how to simplify radicals. Hopefully you all remember how to do that. But this one, 128 is the same thing as 64 times 2. The square root of 64 is 8. So it turns out R of this point is going to be 8 square root of 2. So here's X, here's Y, there's R. Now I need to find theta. So what's the equation for theta? It's the inverse tangent of Y over X. And I'm warning you now, inverse tangents, you have to really keep an eye on because they can trick you at first. So Y is -8 over 8. So theta is the inverse tangent of -1. Now here's the tricky thing. If you were to grab your calculator, you don't need to for this one, but just for fun, if you did, well, let's not even talk about the calculator. Let's just pretend this was a true inverse tangent problem. Remember, inverse tangents, the answer has to be on the right half of the circle. And if we're down here in the fourth quadrant, we write the angle as a negative. So a true inverse tangent of -1 is going to be right there. Because remember, I'm looking for the angle where the tangent is -1. Or another way to say it, since tangent is sine over cosine, I'm looking for the angle where the sine and the cosine are the same number, but the answer is negative. Let me just write down what this is, and then let me make sure that everybody knows how I got this -4. So what we're doing is, since tangent is sine over cosine, I'm looking for an angle where the sine over the cosine is -1. And that's going to happen here at -π/4. However, in the instructions, find the polar coordinates, express in radians, let R be positive. And now here it says the angle can be between -2 pi and pi. So if I read that correct, you would think I can leave my angle to be -π/4. But if I wanted to write it as a positive angle, that's the same thing as 7π/4. Now I'm interested in what they give the answer to be. So my suspicion is I thought they would want to be a positive angle 7/4, but here it says it can be negative. I wonder what they give the answer to be. So they say, see, that's what's interesting. And I wonder if they realize they've done this. Because, and you can correct me if you think I'm confused, because they're saying they want R to be positive. They want the angle to be between -2 pi and 2 pi. So theoretically, -pi/4 would fit it along with 7/4. So it's interesting. Of course, this isn't in my math lab. I don't know if they would accept if someone put -pi/4, whether it should, according to their instructions, count it correct. Interesting. But the key is that you understand what we're doing here. Hopefully that's clear. So now we're ready for problem 17. See what we have here. All right, so now we're doing something different. Now we're getting away from just points with polar coordinates. And now we're looking at actual equations. Now this is a little different. Once again, hopefully when you did the homework, you did a lot of these and understood this. So this is like a polar equation where R equals 11. Let's go ahead and what they want. This is written as a polar equation, and they want an equation in rectangular coordinates. So once again, polar equation is an equation written with r's and thetas, and rectangular coordinate equation is with x's and y's. So the key is now to remember, if you remember when we were converting back and forth between polar coordinates and rectangular coordinates, we have had this relationship where the way we calculate r is r square root of x squared plus y squared. Our polar equation is r equals 11. What we're going to do is we're going to replace the r here with the square root here. So instead we can say, instead of r equals 11, we can say the square root of x squared plus y squared equals 11. And then the way we write these, we don't want to leave a square root here. So if I want to get rid of the square root, when you square a square root, it goes away. Of course, I have to square both sides. Oops. 121. Now, hopefully you recall from the homework that this is actually the equation of a circle. It's a circle and equation of a circle. Now here, I'm going to write r again, although it's different than this r. I mean, well, it may be the same, but typically we think of this r as the radius of the circle. So basically I have a circle with radius equal to r. And that's the equation. So we'll see how they give the answer. What's the standard form of the equation? Rectangular form. So, and then they give you a multiple choice. What does the graph look like? So if I go down to the answer, so here's, okay, so let me just fill this out. What's the standard equation rectangular form? It would be x squared plus y squared equals 121. And then they say, what's the graph of this equation? Well, like I said, it's a circle with the radius not equal to r, radius equal to 11. And the center is at the origin. So it looks like it's center with radius 11. That one's going to be A. And then what's the graph look like? Well, it looks like a circle. So now we can check these answers. X squared plus y squared plus 121. So we have, and then A, and then A, and then A. All right, number 18. Same kind of problem. Here's an equation in polar coordinates. Now this time we have theta in our equation. And they want to convert it to an equation with coordinates. So an equation with X and Y. And then first question, what is the slope intercept form? Slope intercept form is the old y equals mx plus b. The key is you get y by itself on one side. So they want an equation with y by itself on one side. So what do we do here? Well, then you remember that when we were doing polar coordinates, what did we do with theta? We said the way we can find theta is to take the inverse tangent of y over x. Another way to write this, same exact meaning, instead of inverse tangent, we could say tangent of theta is y over x. When I look at this problem, I ask myself the question, what is the angle where the tangent of y over x? That's the same thing as saying the tangent of the angle is y over x. So these are just two different ways to write the same thing. But I like this because what happens now is I'm going to go plug in pi over 4 for my theta here. Since theta is pi over 4, I'll plug it into this equation. And now I say, well, what is pi over 4? What is tangent of pi over 4? Think about your unit circle. Tangent of pi over 4 is sine over cosine. And at pi over 4, the sine is square root of 2 over 2. The cosine is square root of 2. It's just 1. Tangent pi over 4 is 1. So now I have this equation 1 equals y over x. Now, if I want to put it in slope intercept form, that means get y by itself. So I multiply both sides by x. Turns out you end up with an equation y equals x. Just for fun, if you happen to graph y equals x, it's basically just a line that goes right down the middle of the first and third quadrant. So slope intercept form, this first question, that should be the answer. Then they say, what's the graph of this equation? This is what it looks like. We'll see how they describe it. A line in quadrants 1 and 2. Nope, this line is in quadrants 1 and 3. So it looks like a line in quadrants 1 and 3. And then they probably ask you to sort of, what's the graph look like? Well, just what I've drawn. So we'll see if we're correct. So there is the equation y equals x. Second part should be B. Third part should be C. All right. Hopefully, you remember how to do those, and they're not too bad. So what do we have next? Number 19, another polar equation. Transform the polar equation to rectangular. So r sine theta equals 2. Now, if you remember, when we were going back and forth between polar and rectangular coordinates, we had x was r sine theta. Whoops. R cosine theta. Y was r sine theta. And look what I've got, r sine theta equals 2. Well, how about if I just replace the r sine theta 2 with y? Since y equals r sine theta, I can replace r sine theta with y. And then I get y equals 2. And what is y equal to? That's the equation of a horizontal line that goes through y equals 2. So we'll see what the actual questions are. What's the standard form of the equation? Well, that's the equation. What's the graph of the equation? It's a horizontal line. And then what's the actual, if we look at the graph, it's gotta be this one right here. So y equals 2 is my equation. I said D and then B, D and then B. All right, 20. Now we go to a whole sort of different topic. This is plotting complex numbers in polar form. So once again, I'm not going to teach this now because we already taught it in the video lecture. You did problems. So this is just a matter of trying to work out these problems. So plot the complex number on the complex plane and write it in polar form or social form. So first of all, I want to plot it. So when you plot, right, basically you could think of the y as like the complex plane and the x is like the real plane, right? So if I were to graph this, first of all, it's going to be x is like 3, and then y is going to be -3 square root of 3. Let me grab my calculator just to get an idea of what the size of that number is. So 3 times the square root of 3 is like around 5.2. So 3 square root of 3 is around 5.2. So I'm going to go 3 on the real plane and the x, then -5.2. So that point should be right there. Now they give us choose the correct graph below. Looks like it should be B. I'll just tell you what the answer is. And the answer is B, so that's correct. And then they say, write the complex number in polar form. Select the correct choice below. So polar form, remember we do this Z. Make sure I get it correct. Z is R cosine theta plus I sine theta. So really you have to know your R and your theta. Well, the way this number is given to us, we could think of this as X and Y. So let's write that out. So in rectangular coordinates, oftentimes, so our specific problem is 3 minus 3 square root of 3i. But I need to get R and theta. So I use the normal rules we've learned, where R is x squared plus y squared. X is 3, so 3 squared plus negative 3 square root of 3 squared. Oh, sorry. So that's going to be square root of 9 plus, first of all, it's a positive number. And it's going to be 3 squared is 9, square root of 3 squared is 3, so that's like 27. 27 plus 9 is 36. Turns out R is 6. So it's going to be 6. Now I need to get theta. Once I got theta, then I've got my equation, this complex number written in polar form. Just like we always do, theta is the inverse tangent. And once again, it helps that I plotted this because I'm going to have to think about, because they tell me use angle measures greater equal to 0 less than 2 pi. So they want it to be a positive angle between 0 and 2 pi. So inverse tangent of y, negative 3 square root of 3 over 3, which simplifies down to, the 3's cancel. Now, if we're looking for an angle where the tangent is negative square root of 3, I know that that happens. So once again, because tangent is sine over cosine, I want one of my special angles that ends up with square root of 3. And that's going to happen with square root of 3 over 2, 1/2. Right? That's one of my special angles, because this would equal square root of 3. That occurs at pi over 3 or negative pi over 3. And since we want this to be negative, a pure inverse tangent, the angle is going to be negative pi over 3. But they told us they want the answer to be between 0 and 2 pi. So this is like negative pi over 3 here. But instead, if we give that angle, it's 5 pi over 3. So the answer should be cosine 5 pi over 3 plus I times . So really what we're doing here with this complex number stuff, it's really the same thing we do with polar coordinates. Notice here, we're given this complex number where 3 is x, y is negative 3 square root of 3. We had to find the r with our equation we've always used. We find the theta with our same equation, and you get done, and here you are. So there's the answer. You look way down at the bottom. 6 cosine 5 pi over 3 plus I sine 5 pi over 3. It's just a little different at first. Seems a little crazy. This is the kind of thing maybe you would use if you ever take sort of a high-level physics class someday. in your studies, maybe if you're a double E or something. All right, 21. Plot the complex number on the complex plane and write it in polar form. But here's one. I don't think we're gonna have to use all the equations and stuff because this is simple enough. Because 10I, that just means a distance of 10, in a sense, on the y-axis. There's no real component. There's no x component. So it's almost like that's it right there. So we plot the number on the complex plane, imaginary axis, real axis. Now write the number 10I in polar form. Well, if you wanted to, we could use the equations, just it's going to be very simple though. All we have is, it's almost like you could think of this as 0 plus 10I. The real part is 0, the imaginary part's 10. So therefore, there's X and there's Y, right? So R, 0 squared plus 10 squared, square root of that, it's just going to be 10. I don't even need to do, what's this angle here? This angle is pi over 2. So Z should be R. There's no let me write it out just to prove to you. Cosine pi over 2. Now my guess is, since this is 0, I don't know if they would leave that in there or just remove it. You can see what answer they gave. So we go down, so there's our point. Oh, they actually left it in there, so they don't, so it's just like this here. Oh, then the last step. So then another goofy thing at the very end, they say, write the number in polar form, da, ba, da, ba, da. At the very end, write the complex number in exponential form. So this is something sort of new. Exponential form means, another way to write it, R times, where E is your base, this is an exponent. So it's just another way to write this, except 10 goes here, E to the I, and then another crazy way, some crazy math here with complex numbers. So actually this is complex number rectangular form. This is called the complex number with polar coordinates or in polar form. And they call this, or this right here, exponential form. Rectangular, polar, exponential. 3 different ways to write the same thing. All right. I think I'm going to go up until number 23, a couple more. So now, they give us a complex number. Now it's in polar form, and they want it in rectangular form. So this is like an old-fashioned polar coordinate problem, polar rectangular coordinates, where, so let's see what we have here. We know I'll write it down here, 8 cosine of 4 pi over 3 plus I sine 4 pi over 3. This is R, this is theta. Well, we know in rectangular form, it's x plus yi. We know x, r times cosine theta. R is 8 cosine of 4 pi over 3. That's a special angle, right? Unit circle. 4 pi over 3 is down here. Cosine is going to be negative 1/2. So 8 times negative 1/2, negative 4. So x is negative 4. Y is r times sine theta. 8 sine 4 pi over 3. Sine of 4 pi over 3 is negative square root of 3 over 2. 8 into 2 reduced down to 4, negative 4 square root of 3. That should be the complex number in rectangular form. I don't make any mistakes. Negative 4 minus 4 square root of 3 times I. Yep. And then one more, another one. Write the complex number I rectangular form, same thing. Looks like R is 6. Theta is pi. In fact, this is going to be even easier than the last one. So R equals x plus yi. X R cosine theta, 6 times cosine of pi, which is negative 1, negative 6. Y r sine theta, 6 times sine pi is 0. So I believe the answer should be r equals negative 6. Or just negative 6. Not r. Sorry, I should call this z. I normally call it. All right, so that is a lot of polar coordinates, polar equations, and then complex numbers. So the next video we'll pick up with problem 24.